that you actually do know. So drawing a line when given raw data. The first thing is I use the term raw data. Raw data is just like any sort of information that's been given to you. So it could be any context, it could be no context at all, but if they're just giving you X and Y values, they're like X is 1, Y is 3, X is 10, Y is 6, X is 100, Y is 2. I call that raw data. It doesn't mean anything to us. We have no way of interpreting it other than it's just a point. And that's the only thing we know about it. We want to take raw data, which is just random points, and then try to create info out of that. To do that, we create lines. So we try to take raw data and then turn it into a line. The first thing we do is if we're given raw data in the form of a scatter plot, this is a scatter plot. This would be raw data because it's just a bunch of random points. Like nothing really means anything to us other than at this point we have a grade of 50% and they had 12 absences. Like this is just raw data. It's little pieces of data all put together. If you want to draw some sort of conclusion of this, you want to create some sort of line that would best model this information.
So like the line of best fit.
It's called the line of best fit. You should have done this back in like
Physics.
Physics, you do it grade 9 or 8 or something like that, you do it as well, where you just are drawing lines through data. So if you looked at this data, this is a survey of a bunch of kids, and it's their grade and their absences. So for instance, if I took Hannah Lynn, I would check her absences and her grade and then put her on this. So if Hannah had a 40% in the class and she had 10 absences, then she would be this dot right here. And that's not actually 40%, that's low enough. That's 30%. So that's what all these dots represent. It's another student, and it's their absences, and it's their grade. It means nothing to us unless you see a trend. If you look at this information, you can see that there is a trend, and you notice that trend by drawing something called a line of best fit. You draw a line that gets as close to all the dots as possible, and the line has to be straight for this one. So, for instance, I could draw a line like this. And that would be my line of best fit, where you see I'm pretty close. The dots are never too far away from my line. I'm only actually touching 1 or 2 dots. But all the dots are pretty close to my line. It doesn't matter how many you touch, you're just trying to get as close as possible to the dots.
Yeah, but don't you have to have like the same amount of dots on each side of the dots?
No, don't worry about that stuff. So anything you've learned in physics about line of best fits, we're not going to be doing that kind of stuff with it. All you need to understand is you want a line that somewhat looks like that. I could tell that was the line I needed to do just by looking at the dots. I mean, it clearly was on a downward trend, and it went on a straight downward trend. So I call that green line a line of best fit. I would say that this, absences versus grade, is definitely a linear relation. If you have more absences, your grade's probably lower. If you have fewer absences, your grade's probably higher. And this actually does work quite well for grades and absences. So if you take people and you do that over enough people, you usually do see a pretty linear trend. There's some people that don't fit the trend. Right? Like there's some people who might have 1,000 absences, they crush homework at home, and they're doing really well in the course. Those are just outliers that don't really come close to the line. But in general, this data can be represented with a linear relation. Katie, you may. Brandon. Yeah, that's a good way to look at it. It's like, where would the average person land? We can use these lines to interpolate or extrapolate information. Okay, so that means we can use this line to find information. So if I said to you, what if you had a student with 20%? How many absences do you think they would have? And I would look down at 20% and go up until I hit the line. And I would say, I bet they have pretty close to 13 absences. And it's a way that we can now use this data to help us draw information out of other data we collected. That's why we do this stuff. We do it all over the place. So like anywhere in the world that's dealing with information and data, they're doing stuff like this. They're doing it on much larger scales with much more complicated formulas than we will. But they will be taking info and they'll be trying to connect trends to it. That's how you can make a lot of money in stock markets, if you're good enough at detecting trends, which is almost impossible in the stock market, or else people would be rich. Yeah. Is this relevant?
Yeah, it's stop.
No, not relevant. Okay. That's if you're given the scatter plot. You're not always given a scatter plot. In fact, almost all the time you're not going to be given a scatter plot. You're going to be given a table of values. A table of values is when they give you a bunch of x and a bunch of y values. So they would say something like this. X is 1, y is 2. X is 4, y is 9. X is 5, y is 10. And they're just going to give you a whole bunch of information like that. That's called a table of values. If you want to try to draw any sort of line to fit a table of values, you have to turn a table of values into a scatter plot so that you can see it. Your calculator can do that for you. Your calculator can take tables of values and turn it into scatter plots. And then your calculator can also draw the line for you.
Didn't we do this first year?
I don't think we did. We might have in the first semester. First semester we might have in transitional. Second semester we didn't. So that's what this is. We're going to be doing today. We're going to be taking table of values. We're going to be creating scatter plots on our calculators out of it. And then we're going to be creating lines that fit that scatter plot. Doing that is called a regression. So you're going to hear me use the term regression a whole bunch. Regressions is taking data, drawing a line that fits it. All right, to do that, you're going to need your calculators. So everybody pull out their TI-83, TI-84, TI-80 color, TI-80, whatever the heck you guys have. Any of them will work. So take out your TI calculators. Everyone's got one? If you don't, let me know, because you need it. You need to practice this. The first thing I'm going to tell you all to do is just clear your calculators completely. So turn them on. I want you to go second and then plus. And you're going to see the 7th option is reset. So I want you to click that 7th option. Oh, is it your 5th option? Okay, so anyway, find reset somewhere on your thing. Oh, yeah, that's just a different version. Depending on the version, depends where reset is. So second plus, find the reset button, hit it. It's going to say all RAM defaults. You want to pick all RAM. And then you're going to click to reset. And it's going to take you to a screen that says RAM cleared. Now you should see that. What you just did was you reset your calculator so everything's cleared off of it. It's just a good way to start off doing this kind of stuff because it tends that somebody sometime on your calculator put something into it and it's going to screw up our data. So it's good to just kind of reset it all before things start going. All right, this is step-by-step information on how to do a scatter plot. What we're going to do is we're just going to do it together. But if you're ever lost, this is how you create the scatter plot. Yeah.
Doesn't your RAM clear when it dies?
I think so. And there's also a button you can push. You have to also, pardon? No. The mode only matters for if you're doing trig. So if you're hitting sine, cos, or tan, that's when the mode matters. Or if you're graphing things. Awesome. Okay, let's try this. So, here's a question where this kind of stuff is going to be relevant. So it says, the 1 hour record is the furthest distance traveled by the bicycle in 1 hour. The table below shows the world record distances and the dates that they were accomplished. So if you ride a bike for an hour, they want to see how far you can get in that 1 hour, and then this is the world record for it. And it's been set a whole bunch of different years. When you see years like this, I don't like to use the actual value that it says. So, I'm going to explain what I mean. This, we have years and distance. If we want to make a plot out of it, One of these is going to have to be x, and one of them is going to have to be y. Whichever one's going up usually more consistently, like by 1s or 2s, that's going to be your x value. So this is going to be my x values, my year. This is going to be my y value, my distance. Yep.
Would you also get rid of the 19 part? Just have 96.
That's why we're going to talk about why I don't put in 1996.
Oh.
So if you were to graph this thing right now and use these as your x values and these as your y values, you're going to have to graph with x values of 19,000 or 1996. Those are big x values. So when you see years like this, what I like to say is that this is year 0. And then every other year is going to be how many years after year 0 this happened. So this was year 0, or you can even do year 1 if you want. I like year 0. 1998 is year 2. Right? 97 would have been year 1. 98 is year 2. 99 is year 3. 2000 is year 4. 2001 is year 5. 2002 is year 6. 2003 is year 7. 2008 is year 9. Sorry. 2004 is year 8. And I'm writing and reading at the same time, it threw me off. 2005 is year 9. 2006 is year 10. 2007 is year 11. 2008 is year 12. 2009 is year 13. So now instead of saying it was in 2012 this happened, I can just say it was year 16 it happened and figure out a simpler number than that. It makes your graphs a lot nicer. Alright, second part. We only do this, just for the record, we only do this when we're talking about years. I don't think I've ever seen it done anywhere else. It just makes your life a lot easier. And it also makes your life easier when you're trying to answer some certain questions. Okay. Use technology to create a scatter plot to determine the equation of the line of best fit. We want to somehow turn this into an equation where we could use that equation to predict things. First thing you have to do, take this raw data, this table of values, and put it into your calculator to create a scatter plot. So I'm going to hit on, and I'm going to hit stacked right there. It's below the delete button. And then you're going to see the first option is edit. You want to edit what's in your calculator. So you hit enter on edit. And you're going to come up to a thing, it's going to be 3 bars that says L1, L2, L3. So right now, if I look at your calculator, say this 1, this 2, this 3, and so on and so forth. You're going to put your X values in list 1 and your Y values in list 2. Remember, our X values are these new numbers that we put across the top. To do that, my arrow can move around which list I'm in. You'll see it highlighting as I move my arrow. So if I move to the right, I have a different thing highlighted. If I move to my left, I have a different thing highlighted. I want to highlight list 1. I'm going to hit 0 and then enter. And it'll move me down 1 spot. And then I'm going to put 2 and then enter. And then 3, then enter. 6, enter. 7, enter. 8, enter. 11, enter. 12, enter. 13, enter. So all of my X values are now in a nice little column under list 1. If you want to delete, there's a DEL button, so go highlight it and then hit that, and you can delete any mistakes that you might have made. Very critical, beats having to clear everything. Once you've done that, you go to your list 2, and you're going to put in all your Y values in the same order you put your X values in, so from left to right. Because remember, these are points, so you want them to match up. So when my list 1 says 0, my list 2 should say 78.04. Enter. When my list says 2 for list 1, I should have 79.14 for list 2. And so on and so forth. So you're going to put all those things in. Be very careful that you're making sure you put in decimals every time and that you type in the right answers. A small mistake in putting in things can really mess things up for you. once you have those lists filled out, we want to use our calculator to plot those things. To plot them, we got to tell it what window we want. So go to Window, and you're going to see your X min, X max, Y min, Y max. And we're going to do the same thing we did yesterday. Is we're going to put in X minimum that makes sense. What's the lowest X value I have? 0 makes sense. What's the highest X value I have? 13. But I might want to use this information to predict beyond into the future. So I'm going to put, let's say, 20 into there for X max. Because if I want to be able to draw a line and see where it would go into the future. My Y minimum, what's the lowest Y I have? 78.04. I'm going to go a little bit below that so I can see it a little better. I'm going to put 75 as my minimum. So a little bit below. My max Y was 90.6. Again, I might want to predict into the future a little bit, so I'm going to put 100 as my Y max. So everyone should be on their window screen. You should have 0 and then 20, and then you should have 75 and then 100. Awesome. Now, you go second, Y equals. And it's going to bring you to a screen that says stack plots. And it says plot 1, plot 2, plot 3. You see all those? Okay, we want to do plot 1. So hit enter on the first option. And it's going to take you to a screen where it's now blinking for me. And it says on, off at the very top. So it's blinking.
Is it always going to be 1?
Yeah, go ahead. You good? So it should be blinking right now. It should have been off. When you reset your calculator, it turns all your plots off. We want to turn it on, so hit enter on so that it's now highlighted and blinking on for me. Below that is a whole bunch of options. The first option is the type of information that you're going to be doing. The first option, that's a scatter plot. So that should be the highlighted thing. It was already highlighted for you. You shouldn't have to change that. Yeah.
Oh my god.
If you go down to X list, which one was our X value? List 1 or list 2? List 1. So X value should say list 1, L1. Our Y value should, or our Y list should say L2, because that's where we put our Y values. Hit graph. And what you'll get is a nice little graph with all the points put on there for you. Dim mismatch. Anybody else in there? So let's talk through them as a group. Dim mismatch usually means dimensions mismatch. So if you go into your window, there's probably your minimum or maximum is typed in backwards, or maybe just by mistake you hit a button. So you should have checked it. You should have a graph that looks somewhat like this. Mine is dot, 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 dot. Kind of like that. Just a little far apart. Great. That was too high. But it should look somewhat like that.
Is there supposed to be one right at the y-intercept?
There should be one also on the y-intercept that you can barely see, because for that we did call it 1.0 and we're seeing all the way to 0.
And if we called it 1,
If we called it 1, then everything would just be shifted over a little bit, right? Because everything would be over. A way you could fix that is make your x minimum -1, and then you could see that point a little bit better. So if you want to see that point that's on the y-intercept, you could push your y minimum to the left a little bit, and they would see it better. Yeah, Katie. Alright. It's okay. That's why there's step-by-step instructions on another page. Like, because you're going to have to practice this. And there is practice in the practice booklet for, I believe, too. Alright. And we're not going to finish all these today. Like, there's no way. So, well, we might. But you could practice these ones as well. This is nice. It's handy. What it really does for us is it creates a nice visual for the type of equation I probably have. We know 3 types of equations. We know straight lines, which look like this. We know quadratics, which look like this. And we know cubics. which look like this. If you were to predict a line that would generally fit this, what would you predict? Linear, quadratic, or cubic? Linear. I would predict linear. Sure, there's a little bit off, but generally, if I could draw a straight line through these things, I'm pretty close. That's left-handed. Like, I can get pretty close. So there's a good chance that this will create linear regression, a straight line. If I told my calculator, I want you to turn this into a cubic regression, it would do it. If I told it to turn it into a quadratic, it would do it. But neither one of those would make sense. A straight line would make sense. And if you look at the data and consider the question, a straight line also makes sense. Am I ever going to have a world record that goes down? My world record's always going to be improving, and my years is always going to be going up. So that means I'm always going to be gradually going up. And if I went down in my data and we thought about it, if I went back to 1980, I would have a world record that's smaller. If I went back to 1950, I'd have a record that's smaller. This is clearly a linear trend. You have to be able to recognize what type of trend you have by looking at the data and thinking critically about it. Now, you have to tell your calculator to do a regression, to draw a line or create a line that makes sense. So to do that, you are going to go Stat. And you're going to click over to the right one. And now you should have on the top, you should have 3 options. You should have Edit, Calc, and Tests. You should have the word Calc highlighted. So that's telling your calculator, I want to highlight something. I want to calculate something. If you look at your options, you see lin reg. Lin reg. What do you think that stands for? Linear regression. So you want to tell your calculator to do a linear regression, which is what we want, right? We want to draw a line. So you go down to lin reg and you hit enter. And it's going to bring you, it depends on your calculator. So some of your calculators are going to jump straight to your screen and have an answer all of a sudden. And a lot of you are going to have a screen that says, on the top line it says lin reg, and then it says x list L1, y list L2. People on a list, something that looks like that? Should look something like this. So you went stat over, yeah, and yours jump right to it, that's okay. So yours will also jump to a Tay-Tay. Yours should also jump to the answer. If you have a TI-83, you're going to jump straight to the answer. If you don't, and you have a calculator like myself, or one like this, you're going to jump to a screen that now is trying to let you edit some things. Yep, good. Okay. At this point, if you're in this calculator, all you're allowed to do now that the other people aren't allowed to do is you can change your lists up. So you can change your X variable to be list 2 if you wanted. You wouldn't want to do that. So you're just really confirming that it's all correct. So mine says X list L1, that's right. It says Y list L2, that's right. So I just go down to calculate, and I hit enter. When I hit enter, my calculator brings up a whole bunch of stuff. It's going to bring up, spin right back to the top. It says y equals ax plus b. That's the first thing it says. That's our general form for a linear equation. The next thing it says is a equals 0.85. It's a crazy decimal. 858. We'll leave it at that. And then it says b equals 77.79.
So say you have one number wrong.
Let's say it's 7.
So say you go 78.06 instead, are you going to get the wrong numbers?
So if you screwed up putting your data at
So I got
all,
wrong numbers.
yeah, if you put in your data and you missed a decimal point or anything like that, it's probably giving you different numbers. How many people got these as their 2 numbers, A and B?
Oh, I know.
If you did not get that, then you put something in one of your lists wrong, and it's probably 1 digit, probably something so minuscule. Now, it won't hurt you if it's one little digit. So if you had 0.859, you're still going to get the same right answer when you actually do the question. It's not going to be that far off. But if I had a equals 6, that's such a big gap that now when I go to use this information, I'm going to be a little bit pooched.
So
Right.
if that's the case, then you just go back into your list and just do that.
Yeah, like you're not going to know like if you're way off or not, right? Because you're not going to be able to compare with me on a test. So yeah, you're just going to have to go with it.
Yes.
But I'm just telling you not to freak out over like if you're like, oh, I'm not sure if I put in the 10th decimal point right. But if I put in 181 instead of 81, that'll throw me off. Yeah.
Everything just disappeared.
So then do it again. Go
But I don't, that's the thing I don't know how to do.
stat,
Stat.
click right,
Oh, right, okay, got it.
go then right. Okay. It's a lot. I know it's a lot of calculator work. So you guys aren't too thrilled. Okay. That just created a line for you. It created a y equals ax plus b line, and it told you what a and b were. So this question was, create an equation, right? Determine the equation of the line of best fit. This that you just did, that's your equation of the line of best fit. So my equation is y equals 0.858 x plus 77.79. That's my equation for a line of best fit. And you can get this thing to go into your y equals by hand. So I could go y equals and type this in. So if you're like, this is enough calculator crap for me, I'll just type in all these decimals on my own. Feel free. Or you can go y equals. You go to y1. And you're going to go vars. So it's right beside your clear button. V-A-R-S, vars. You're going to click on that. You're going to go down to your 5th option, which says statistics. And then you're going to hit enter on it. It's going to bring you to another list. On the top, you should see something that says EQ. That means equation. So go over to EQ, and you'll see reg EQ. That's your regression equation. And hit enter on that. And you'll notice you have all those crazy decimals all of a sudden in your y equals. If you hit graph, it'll now draw that line of best fit through your data for you. So I'm going to write out that info for you because that info is not on there. So if you want to just use that cheat to draw the line instead of having to do it yourself, so I'm going to put it in this little spot over here. So draw a line. So to draw the line into your y equals, you're going to hit bars here. Then you're going to go to your 5th option.
Bars.
Which is
But you have to make sure size has nothing different. Yeah.
So you hit bars, you went to your 5th option, which was statistics, and hit enter. Then you're going to go to EQ. Along the top. So you're going to go right arrow 2 times. And then you're going to pick reg EQ.
That was number 1.
Yeah, the first option. So you went y equals, and then you clicked all those buttons, and it puts it right into it for you. It's nice because then you don't have to type out all the decimals. Like it saves you some effort of like writing them down, typing them in your calculator, and then checking. For your quiz tomorrow, you're going to be doing regressions. Yeah. And at a decent amount of them. So the point of it is, if you look at your graph right now, you now can answer a bunch of questions. So for instance, you could interpolate information. To interpolate information means to look inside your data range. So my data range is from here all the way out to here. Interpolate is predicting anything on the inside. To extrapolate is to draw information from beyond that data. Yes, sir.
Is there a way to do it where you like go and you find an x value and go up to the line and then find where that would be for y?
Yeah, that's what we're going to do.
Okay.
Yeah. So, question B, like the reason why all of this was useful is now you can draw information from what you just did. It says a possible world record distance for the year 2006 to the nearest 100th of a kilometer. So we didn't have a 2006 piece of information, did we? What year would have 2006 been? It would have been year 10. So they're saying, what happens when x equals 10? In your calculator, if you know an x value, which you do, you just go trace 10 and then enter. It's not really, oh, sorry, we missed something. You gotta turn your plot off. So once you've drawn a nice little line of best fit, go back to your graph, so y equals, and along the very top you see plot 1, plot 2, plot 3. Go to plot 1 and just unhighlight it. So hit enter on it and then it'll turn it off. And then you'll have just your straight line, which is what you want. You don't want your plot on. Because if your calculator will try to find x equals 10 on your plot, x doesn't equal 10 on your plot. So it's going to be very confused. You go y equals, and right on the top you see plot 1, plot 2, plot 3. You move your cursor up to that, and then you just go and click on it, and it'll either highlight it or unhighlight it. You want all of them to be unhighlighted when you're actually using your line now. So you click on it, it should be blinking.
Yeah.
Can't move off of it now? Is it highlighted?
Oh.
You've turned it off, yeah. Yeah, yeah, Kendra.
I got this here transfer from my
Oh, yours work? Oh, cool. Some of them don't work. Like mine doesn't work if I leave my plot on. So I turn it off. So I'm straight on my straight line. Yeah, Jake.
I have no idea what's going on. Like, so, it's not,
Let's see. What's it look like?
so, traffic,
Yep.
bars,
Oh my god. You go y equals. And then you go bars.
5,
Now it's a derivation. Now you got it?
So this is what you're supposed to do?
So if you haven't graphed your line yet, on your calculator, you can figure out where x is going to equal 10, because that's what they wanted to know. They wanted to interpolate, what do you think the world record was in 2006? That was year 10 for us. So on your calculator, you should be on your graph, you have a beautiful straight line, you hit trace, and then 10, and then enter. And it's going to show you where on that graph the year 2006 was, and it's going to predict the world record for you, which is our y variable. It predicts that it would be 86.378. That's what I got. So we use this stuff to try to predict things. That's why this is so useful. It's why it's actually like an extremely good skill if you want to enter into the world of economics or business or anything like that. It's why they recommend -2 for business school and not -1. Because you don't do this in -1. You do it for -2. So that's why this is like, these courses are still academic courses. It's just not engineering academic.
Can we use this for cheating in -1?
No, won't do it. Okay, you could also, just for fun, if you're like, oh yeah, okay, what's the world record gonna be in 2012? So that would be year 14, 15, 16. I could go trace 16, enter. This predicts the world record to be 91.5 by the year 2012. That would be extrapolating data because that's beyond our original data set.
Wait, you mean second trace 1, then 16?
You can just hit trace and it'll do it for you.
That's,
Yep, just trace 16, enter.
it's,
It pops up.
So are you on your graph?
yeah. Here, what? Trace?
That's what she did. No, Jane, we're good. Okay, so I have y equals, put it up there, enter, graph,
Oh, okay.
one.
Alright. Some people don't like using the calculators to figure things out like that, and that's okay if you don't. What you could do instead is you created a linear equation. You could do it by hand by making x equal 16 and then just calculate that number. So if you're like, I don't like the calculator stuff, you could do it by hand. So you could just put 16 in for x, hit enter, and you're set. When we did this, and we put x equal 10 in, what was our world record again? 86.37. Okay, look at the next question. Compare your estimate to the actual world record. We were pretty close. Like, we said 86.3, they were 85.9. That's pretty darn close. So that shows you that these regressions and these predictions are actually pretty decent most of the time. And like I said, in the business world, you get really good at this stuff. You could try. So you have to figure out what number 2030 would be, and you could try to extrapolate that information. So you would say 2030 would be this would be 14, so it would be year 34. And then hit enter, and you could figure it out. So for trace, 34, enter. You have to make sure your window is big enough to go out to x maximum of 34. Ours
Is that where mine said they're invalid?
Yeah, because you said, I want to see x equals 34, but in your window you said x can't go beyond 20. Right? So that's why it didn't make sense.
So, like, if you wanted to predict what it was in year 16 or year, like, 18, the higher you go up, the more, like, the larger...
You're probably off.
Yeah, okay.
Interpolating data is usually much more accurate than extrapolating data. Because for something like this, it's hard to predict like the future or to know what had happened before. So for instance, maybe in 20 years, they progressed bikes somehow. So now you're allowed to use a bike that's got something on it. Or you're allowed to go downhill or something. And now the world record's like actually way better than that. So extrapolating data is always less accurate than interpolating data. That's good to know.
Wait, hey. Interpolating is what again?
Interpolating is inside the given data. Extrapolating is going beyond the points that we made. They don't really use the terminology very often, interpolate versus extrapolate, but it is terminology that could be used. I don't think it's in that. All right. That's creating a regression. It's challenging. It's a lot of calculator work. You get good at it by practicing. Remember that the info is right here. Okay? So if you want to go and look and try it on your own and do it step by step because you got lost, do that. We're going to do one more really quick. We got 15 minutes. So we're going to take this question and we're going to try our best to do a regression on it. So we have some raw data. We have someone selling shirts, and then we have a cost per shirt. You have to choose which one's X and which one's Y. I'm going to say the number of shirts is X, and the cost per shirt is Y. You really, if you screw it up and you get it backwards, it doesn't really matter. But this just looks better to me. I'm going to say the number of shirts, I'm predicting that I can choose that. I can't choose my cost. So this would be my input, which would be number of shirts. My output would be my Y, which is my cost per shirt. I'm going to have to put this into my calculator. To put it into my calculator, I'm going to go stat, edit. And it takes me to list 1 and list 2. Notice that your old stuff is still in there. You're going to have to delete it all. You can delete it all by hitting the DEL button, which is just delete. So delete everything out of your lists.
You can press like 20 times.
You're going to press it a lot of times so you can delete one at a time.
You can go up to the L1 and then press delete.
And delete something.
No, that deletes the whole...
Oh, that deletes the whole list. Don't do that.
Oh, you don't want to delete the whole thing?
No, because see how L1 is no longer an option for you?
Yeah.
You just deleted the possibility to have list 1. Do you have L1 there as a possibility? Oh, for me, it deleted out the entire thing.
Can you fix that?
So,
It has to be 6.
5, 2, you should be putting in these numbers. The order you put them in doesn't matter, but they have to go in the same order. So if I go 500 is my first number in list 1, 3.25 has to be my first number for list 2. Don't try to put them in from smallest to highest, or highest to smallest. Just put them in the way they're showing up. Remember, these are points on a graph. So if this is X, this Y has to be next to it. So I'm going to go 500, and then 700, then 200, then 460, and 740. In list 2, I'm going to go 3.25, 1.95, 5.2, 3.51, and 1.6. And now my calculator should have list 1, list 2 filled out for it. Now we want to graph that to look and see if it's like making sense. We can predict what it looks like. To do that, you need to make a window that makes sense, right?
Do you have
So-
to do like the 0 again for like the, oh wait, you said you only did that for years.
Only a year, you're good. Yeah. Now hit window. So we need to make a window that makes sense. So what's the minimum number of shirts that I could buy? You can buy 200. You can even go a little less than that so you see that point. So I'm going to say my X minimum is 100. Say like, okay, I'll buy 100 shirts. That'd be the minimum number of shirts I buy. My X maximum, they went up to 740. I'm going to go a little beyond that. So I'm going to say 800 shirts is the most I'll ever buy. If you want to go up to 8,000 or something, or 1,000 or something like that, that makes sense too. Don't buy 8,000 shirts. That'd be fine. It's just that at this point of 200, you're now going to be right on that intercept. That's all that's going to happen to you. Y minimum. My lowest price I ever had was 1.69. I'm going to go a little below it. I'm going to say $1. My highest price I ever had was 5.2. I'm going to go a little above it. I'm going to say $6. So I've set my window now. I'm going to go and turn the plot on. So that's when you went second Y equals. It says stat plot at the top. And you're going to see all those plots. It says plot 1 off, plot 2 off, plot 3 off. That's what it's saying on my screen right now with some other mumbo jumbo. I'm going to click on plot 1, and I'm going to turn it on. And I'm going to make sure that my X is list 1 and my Y is list 2. Just double check to make sure it says that on your screen. That says X list, it should say L1. Y list, L2. That shouldn't ever change unless you change it. So that should always stay that way. Now graph it. And if you graph it, you should get something that looks like this. I've got a dot way up here, I've got 2 kind of in here, and I've got 2 more kind of in here. That's kind of what mine looks like, rough sketch. The reason we do all this is because stat plots like this, they help us predict the type of equation we need to make. If you could look at this and tell, yeah, that's linear for sure, then you could actually skip those steps. However, when we get to quadratics and cubics, it's going to get a little challenging to tell which one's which. So it might be nice to look at a picture of it. Now we're going to create an equation. So we need to do a regression on this thing. To do a regression, you go stat, you click over 1 so that you're under the calculating option. And you're going to pick the regression that you think makes sense. So you see how it says lin reg, quad reg, cubic reg? You're choosing between a linear regression, a quadratic regression, or a cubic regression. What do we think this thing is going to be? I think it's going to be a straight line, so I'm going to do linear regression, which is my 4th option on my calculator. And then some of you, it takes you straight to the answer. For some of us, it takes me to a screen that says X list L1, Y list L2, and then down at the very bottom it says calculate. I want to hit enter on calculate. It says Y equals AX plus B. A equals negative 0.0065. B equals 6.5. That means if I wanted to create an equation that would fit this data nicely, my equation would be y equals negative 0.0065 x plus 6. Right? You can create that equation by hand. If you want to graph that equation so that you can use your calculator, you could type this one in by hand really easily. Small decimals. If you want to use that trick, you go y equals. You should be on your first option. Make sure it's cleared now, so hit clear so it's blank. Vars. Fifth option. Right arrow twice. Reg EQ. And now all of a sudden it puts it in form. With a one like this, I would have just typed it in my hand. If it's those ones we saw like on the last question where it's like 2 million decimals, that's when I switch. If I graph it, I now have a beautiful straight line that actually goes through all those points. I can now use that line to help me figure out information. Let's do question C. So that's a little different. It says, use the linear regression function to extrapolate the size of order necessary to get 1.5 per shirt. Extrapolate means you're going to be getting info outside of the data, so no one's ever done this before. It says you want a shirt cost of 1.5. That's a y value of 1.5. Your calculator doesn't know how to easily find y values. It only knows how to easily find x values. So if you put an x in, you just do that trace trick. For this, what you have to do is when it says they want y to equal 1.5, you make that a second line on your calculator. So on your calculator, you're going to go y2 equals 1.5, and then graph it, and you'll have a new line that goes right here. What your calculator can do is it can figure out where two lines intersect each other. They're going to intersect each other at y equals 1.5. So you go second trace, and there's the intersect option. So you hit the intersect option, move your cursor so it's close to it. So it's somewhere near where they intersect each other. Hit enter, enter, enter. And this says that y equals 1.5, x equals 769 shirts. Notice that I round down to the nearest whole shirt. I'm not going to get 0.23077 of a shirt. I highly suggest, for your quiz tomorrow, that you practice these last two. They are not going to be linear regressions. So when you look at them, it's going to create a different shape. This one is quadratic regression. Process is the exact same. Instead of hitting len reg, you're just going to hit quad reg. This one, I believe, creates cubic. But look at the data and see if you could tell that. See if you can be like, yeah, okay, that's definitely not a quadratic. Telling the difference between quadratics and cubics is tough. Because cubics have like mini quadratic shapes in them. Right? Those little maximums and minimums. So that's why they can be challenging. So make sure you graph them and actually check them and see what you get.
And was our calculator going to let us put in every single one of those?
Your calculator will let you put in all that info. You could do like a list of a million things. Yeah.